Now that we have created an action interface called Move, in this lesson, we will see how we can use our custom action interface using Python. To do that, we're going to open the terminal, and then we go to the workspace, and then we go to the package. From the package, we go to scripts. Inside of scripts, we're going to create our file. This file, we use touch to create file. So this file, we're going to call it move underscore, just like we did for C++, move underscore action server. Okay, .py. All right, so the file has been created. We can then go back to the workspace and then start writing the code. Open VS Code. All right. So what we're gonna do here is to open the action server. Okay. So basically, we want to write an action server where you can tell the turtle in the turtle sim to go a particular distance, and then as the turtle keeps going, you can get a feedback and you will also get results when the goal is completed. So remember, actions are divided into three parts: the goal, the results, and the feedback. So we want to make the turtle move forward at a particular distance, and then we want the turtle to give us a feedback of how it's going, and then we also want it to tell us when it has succeeded in achieving the goal. This is quite different from service and topics. So the first thing we're going to do is to put our shebang. You have to put the shebang. Okay, so after the shebang, we import the Python, the Rust client library for Python, which is the entry point for every other thing we want to do. So from there, we import the node. So the node, and then we do import node. Because we're using action, we need to bring in the action server as well. So from rclpy.action, then we import action server. So we import the action server. Now the next thing we want to do, because we'll be using geometry messages, the cmdevil topic, to move the turtle forward, we need to call the message type. So from geometry messages .msg, we want to import twist. Okay, now the next thing we want to do is to now bring in our own custom action file, which is here, move.action. So to do that, you say move, and then remember it's under the package called turtlecontrol.action, and then we want to import move from there. Okay, so because we're going to use time, let's import time, and you see we're going to use that later. So now, as we usually do, we're going to create a class and call it move action server. Yeah, we call our class move action server, and then it takes a parameter called node. Okay, from there we define the constructor. The constructor is underscore init. Then we have self. Okay, so super init, Then what we pass in here is the server, the go underscore action, the name of the node. So this is the name of the node. You shouldn't confuse it with the name of the server. It's not the name of the server, but it's the sorry, it's not the name of the action, but it's the name of the node. Okay, so we have self dot. What we now want to do is to create an action file. So I'm just gonna call it action server underscore, and there was say is equal to action server. Now this takes some parameters. We have 4 parameters in this part. So the first is self. Then we have another parameter. The next parameter is the message type, or in this case, we call it the action type that you want to use. So the action type we are using is called move. That is the action type, followed by the name of the action server. So the name of this action server, we're going to call it, or the name of the action, just like you have topics, you have services, the name of the service, the name of the topic, like you have for geometry messages, which is this twist. It uses a topic called cmdevel. Cmdevel uses this message type. So our own move, we're going to give it a name and call it goal. So that is the name of the action, and then we call self.execute callback. We are going to define execute callback later as a function, a callback function. Okay. So now that we have this, we can just format this way. All right, that's better. So the next thing we want to do now is to create a publisher. Call it self.pub. Let's just call it pub. It's equal to self.create publisher. So create publisher. Now to create publisher, the first thing we're going to put there is the message type. The message type is twist. The topic we want to talk to is called talk to one. So the topic we want to communicate with talk to one cmdevel, followed by the QoS, the quality of service, which is 10 is the recommended for publishers and subscribers. So the next thing we want to do now is to create another function still under the class, and the function is going to be the execute callback. Execute callback. So the execute callback we mentioned here, we haven't actually created it, so we're going to create it here, execute callback, and then it takes in 2 parameters. The first is self, and the second is called handle go. Okay, handle go. All right, brilliant. So we move on. What we want to do here is to first set our parameters. So the first we're going to say is self.getLogger. Just want to be sure that we are inside this function, and to do that we're just going to say getLogger and then info. So then we want to say executing go. Okay, when we are here, then we are sure that we're trying to execute the go. Okay, remember we have go, result, feedback. Okay, so the next thing we set is speed, which I'm going to give it 2.0. Speed is 2.0. We create an instance of twist, and that instance of twist we call it speed message, which is going to be an instance of twist. So we also create another one called is forward. So it means we can tell the turtle to go forward or backward. We can specify the direction at which the turtle should move. So we're going to give it a default value of true. Okay, so we're now going to say that if the turtle is to go forward, then we want to give it we want to make the speed positive, If it's the other way around, then it should be a negative speed so that we can know it's going backwards. So I'm just going to say if is forward is true. If is forward is true, then I want to do something. What we want to do is make speed message dot linear. Remember, it's an instance of twist, so you can access the member functions inside, and then we have x, all the variables inside. So then we have absolute value of speed. Remember, speed is 2.0, so it means this thing is going to move 2.0 meters per second. But what if we wanted to go back? That's where we say else. If the direction you want it to go is backwards, then we want to say speed.msg.linear.x should be set to negative, still the absolute value of speed. Yeah, so even if you put in -2, it's still gonna say -2 and make it 2 plus 2, but then the outcome is still gonna be -2. All right. Okay, so we are not setting this direction from the speed. We are setting the direction from the is forward, from this Boolean variable. All right, so the next thing we want to do now is we want to be sure that we don't have garbage inside the other variables. Now, when I say the other variables, I mean linear y, and we have the z2. We want to be sure we don't have garbage inside, so we want to be sure that we are not moving in linear y and linear z. So we do the same thing, speed, okay, and then we put angular x 0. We want to be sure that we are not turning, we're just moving forward straight in x direction or in the x axis. All right, so when we are done with that, the next thing is to create a time variable, because we know that speed is displacement over change in time. Okay, so it's displacement over change in time. We're just going to create a time variable here. Now this time, you can see I put an underscore. It's different from this time here. Okay, so speed the time. The way you get time in Python, in Rust client library for Python, is to use self.getLogger. Oh, sorry, getClock. So it's the getClock that gets the time, but you need to specify which time. So we will say now. We want to get the current time right now. And the next question is, what units do you want to get the time? Is it nanoseconds or seconds? So I'm just going to use this. Okay, so now this is a tuple. Our time right now is a tuple, you can see. So our time contains seconds and nanoseconds inside of it. So we need to tell, we need to create a variable now to pick the one we actually want. So I'm just going to go to the next line and say t0, that's our initial time, will be time underscore and then 0. Okay, so remember, it's a tuple and we have two values inside. You can access the first one with 0 and the second one with 1. So the first one here is the seconds, which we're interested in. The next one, the other one, if you use 1, then you're going to get the nanoseconds. Okay, so we are getting the seconds. All right, so we want to create another double variable. So it's going to be offload, as the case may be. So we call it current distance, and current distance is going to be 0.0. We initialize it to 0.0. We create something, a feedback message, okay? Feedback message. And then what we want to put inside feedback is this feedback. Remember, this is the feedback here, the feedback variable. Okay, so to access that, we use the move, which is the message type, just like we did for twist. the message type is twist, so we can put it inside speed.msg. But for this one, it's move. Then we want to access inside move. We want to access feedback. We want to access feedback. Okay, so when we access feedback, we want to put some kind of information. We want to put that information inside. Not sure why this is showing this way. From total control, import move. I expect it to, show like color, almost like green here, but it's okay. Move action server. Move. Okay. All right, that's fine, no problem. So move, and the next thing we want to do is to use a. So what we're going to do now is to create a while statement. So while current distance is less than the desired distance. Now this is the desired distance, but the desired distance is our goal. So we're going to use the goal handle to handle the desired distance. So we're going to use this goal handle or handle goal, anyone, to get the desired distance. But anyways, I'm just going to call it goal handle. Okay, so then we use goal handle dot. So when I use the dot operator, I want to access the goal. To access the goal, I'm going to use request dot. Then the name of the goal is desired distance. So we're saying that when current distance is less than the desired distance, it means we have not gotten to where we want to get to. Then this particular line or the line next should run, or the block next should run. And they want to make another check just to be sure that ROS is actually working. So you're going to say RCL supervisor. Okay, if that one is true as well. If it's true, then we want to run something. The first thing we want to do is get the time. So I'm just going to copy this. Okay. So get a time. When you get the time, then store it in T1, which is the new time. Now, remember, it's change, it's displacement or distance over time or change in time. So we're going to access time underscore. All right, so from there, we can now say current distance is equal to speed. Remember, speed is distance over time. Distance will be speed times time. Speed underscore message dot linear for x, okay, times the distance now will be t0 minus t1. No. The new time minus the initial time. All right. So when we get this, then we want to publish the speed. So basically, we're saying that as far as we're in this loop, we want you to keep publishing the speed until this condition no longer holds. So I'm just going to do self dot publish. That's our pub, the publisher we created here. Pub. Okay, publish. Then we want to access publisher. Okay, pub publish, and then what we want to publish is the speed underscore msg. Okay, so after publishing the speed, The next thing we want to do is to also publish the feedback. Okay, so we're going to put a message here and say feedback message dot feedback, so we can access the feedback from here. Feedback message dot feedback is equal to moving forward. Then here we can say we can now publish the feedback, and to publish the feedback we use the goal handle dot publish feedback. Goal handle dot publish feedback, and we have feedback underscore MSG. So we want to publish this feedback underscore MSG. What is inside is what we want to publish, and it's going to publish moving forward. So as long as we are in this loop, and we need to see the feedback, it will always publish moving forward, moving forward, moving forward, as long as we're in here. So immediately we come out of here, it will no longer publish this feedback. Okay, so then we need to tell the time at which this loop will be running. So let's just say time.sleep is 0.1. Okay, so 0.1 seconds. So it's very fast publishing, always, running this loop at 0.1 seconds. And this is the time responsible for that. Okay, so now we can move to the next thing. The next thing is we want to create, when we are not inside this loop, then it means that we are done with the goal. We want the goal handle dot succeed. Goal handle dot succeed. So when we are done with this loop, then we want to show that the goal has succeeded. From there, we also want to make sure that we are not publishing the message again. So that's linear.x. we are not publishing the speed as 2.0. So we're going to set the linear speed, and then we publish it again. We want to make sure that the turtle has stopped. Okay, no, we're using pub dot publish, and then what we want to publish is speed underscore MSG. That's great, brilliant. So after that, we now want to create a result. Remember, we have the goal, the result, and the feedback. So the result is status, and then we go back here, say result is equal to move dot result. Result is move dot result, and we're gonna create speed. Oh no, let's say result dot status. Because result is an instance of move result, we can access the status inside move result. Okay, move result dot status is equal to finished action server. So we can just tell when we are done, it should tell us finish action server, and what we want to return is we want to return result. Okay, we want to return result. We are done with that. The next thing is to go and create the main function. So def main, and then we put in the args, which is none, the argument. The next thing is rclpy. Remember, without initializing the node, it's not going to work. Dot args, and then we create an object of the class move action server. We create an object of the class I'll call it move action server. Just gonna take move action server. Okay, so we spin this object that we're creating, dot spin, and then we call it move action server. So we have to call our main inside if. So if underscore name is equal to main. So the next thing is to call main. All right, that is beautiful. That is beautiful. I don't know if there is anything wrong, but I expect this guy to be green, but maybe it's because it's a custom file. Okay, it's fine. And I hope it's on the Turtle Control script. Oh, is this script? Yeah, script. Okay, yeah. All right, so everything is fine, I believe. So we now go to the CMake list. Inside the CMake list, we're gonna just gonna copy this, and then inside the CMake list, we create the script, and then paste it. Oops. Okay, I'm gonna copy again, and then paste it. Okay, move action server.py. All right, everything is fine. The next thing we want to do now is to compile and run. So I'm just gonna go make this big, split my screen. I'll split this too. All right, so let's run the code. Calcon build. Okay, Calcon is building. All right, build successful. So the first thing I want to do is to install setup.bash. I need to set up my workspace. If I don't do that, the bash shell or the terminal will not recognize my commands. So I need to do it everywhere. Okay, so let's run the node ROS2 run Turtle control, and then move action server.py. Beautiful. So it's running right now. We're gonna run the TurtleSim node. So I'm just gonna say ROS2 run TurtleSim. Sorry, TurtleSim. And then TurtleSim node. Okay, so we have the TurtleSim running. Now remember, we only did the action server. We have not written the action client. But in ROS, you can actually send your goal from the terminal without writing an action client. And this also goes for message files or services rather. So if you have a service server, so if you have a service server, you can always send your request from the terminal. So you can send your request from the terminal, and the server is going to get the request and return a response. So you can do that without even writing a service client. Okay, so that's what I'm going to do now. I'm going to bring this here and say always on top. Okay, and I'm going to run ROS2. The way you run it is to do ROS2 action, and then after action, you put in the send goal, then the next thing that follows is the name of the action itself. So the name of our action can be seen here, and this is it, goal. So this is the name of the action, goal. Okay, so we're going back, and then we put goal followed by the type of message or the type of action that Go uses. So Go uses total control underscore, sorry, total control slash action slash move. Okay, then the next thing is you need to pass in the goal that you actually want to send. So we are going to put it this way. The first thing is to use your inverted comma, and then you open a curly bracket. So we're going to put a desired distance. Remember, that's our goal, desired distance, and then you put in your value. So I'm going to put in 4, and then you close your curly bracket and close the inverted comma. So this is how you send a goal from the terminal, even without having a client server, having an action client rather. Okay, now you can see we got executing goal, which is what is in the code, and then here we also got finished action server. That is the status we set, that when this goal is finished, it should show us a result, and the result should be finished action server. And then you can see a goal finished with status succeeded. So that is fine. Everything is working perfect. So there are other things I want to show you. The first thing is that let's run the action server again. Okay, so the action server is running right now, and then I want to show you something. I'm going to run ROS2 run total control, and we're going to call, oh no, ROS2 action and then list. Okay, so we can see that the name of our action is goal. All right, the next thing we can do is ROS2 action. We can get information about this goal, and then we're going to see it here that the name of the action is goal. It has no client, but then we have one server running right now, and the name of the server we're running right now is goal action server. All right, so that is it. Now we're going to run the TurtleSim again and show you how you can get feedback. So this is how you can get feedback. Let me make this here. So to get feedback, you're just going to run a similar line of code, but then after send goal, you pass in feedback. So after send goal, you have feedback, and then when you press enter, you're going to see the feedback. So it's telling us moving forward until it got to the right place, and then it says finished action server. Okay, so you've learned how to create an action server with Python.